Okay, so today we're going to be talking about DMA 40, section 7 through 10. Now, in this section, I know section 7, 8, and 9 deal with a lot of word problems. And the obviously the bad news about word problems is I can show you how to do maybe 4 or 5 examples, but then when you get to another word problem, it has different wording. Because one problem we can talk about how much it costs to go to the store and buy some shoes. The next problem can be how many cups of sugar should I add for this certain recipe. So all word problems are just different. There's no one solution to that's going to solve all. Then you know how to set up all word problems. So hopefully by me doing maybe about I think I have maybe about 7 examples of word problems, maybe less. 7 examples of word problems that hopefully you can kind of get the idea of what I'm doing on how to set it up. Because the main thing about word problems is just setting it up. I know that you already been through the first 6 sections and just and solve for x, solve for y, or x or y, and then solve the word problem of the equation that way. But now, where I'm giving you a word problem, and you now have to kind of set it up. So basically, this session here is pretty much all I'm going to do is show you how to set it up. I'm going to assume that everybody knows how to solve for x at this point. If not, then after we finish the lecture, if you have any questions about solving for a certain problem, I'll be more than happy to answer that question. So let's start with the first one. The question here is on the bottom. This one came from actually section 7. It says a 16-foot piece of string is cut into 2 pieces so that the longer piece is 1 foot longer than twice the shorter piece. If the shorter piece is x feet long, find the lengths of both pieces. Now, obviously, reading that whole problem kind of want to make you throw a book across the room, or it just gets you frustrated because it's just too much stuff going on. So I would suggest the best thing with word problems that you can do is read it piece by piece, meaning maybe 2 or 3 words at a time. Write down your information or write down the key things off to the side or highlight the key information in the word problem that you can be using to create your equation. The second thing that you need to do is also draw pictures. I think visual kind of helps a lot when doing a lot of these word problems. If you have what's the word problems talk about visually, you can probably see the big picture and how to solve for it. So let's start off with the first part of the problem. A oops, it says a 6 feet piece of string. So let's do that first. Now you have to pretend from here all the way to here it's actually going to be 6 feet. So from this end all the way down to this end, we'll say it's going to be 16 feet. We say the string is going to be cut into 2 pieces. Now, when it says cut into 2 pieces, it did not say it's directly cut in half. It just said it's cut into 2 pieces. So the cut can actually be maybe right here. So it does not matter where you put your cut at. So the next part says the longer piece. So looking at this one here, would you all agree that the longer piece is probably this side? So pretty much from here to here is considered to be the longer piece. And then the shorter piece is pretty much from here to here. So we have the longer piece and the shorter piece. And it's trying to tell us now the longer piece is, this word is right there, that's going to be an equal sign. So the longer piece is 1 foot longer than, so if something is longer than, if I'm thinking about adding, subtracting, multiplying, dividing, longer than will probably be plus sign. If I say twice the shorter piece, if I want to double something, don't I multiply it by 2? And the shorter piece we already said is going to be our x. So 1 foot longer than twice the shorter piece. So down here We're going to designate our shorter piece to be x, and our equation for this one is going to be 2x, 1 plus 2x. Now, I'm going to put this in green so you know this is just an example or a made up or response. Would you all agree if the shorter piece is 6 feet, what would the longer piece be if the whole thing is 16 feet? It'll have to be 10. So basically, how do we get to that 16 feet with the 6 and 10? Well, I took both of these, the 6 and the 10, and added them together. So basically, if I knew what this was and I knew what this was, all I have to do is take both of them and add it together. Both of these added together will create our 16. So this right here kind of explains this is actually going to be our equation. So we have x plus 1 plus 2x is equal to 16. And then we go from there by collecting like terms and solve for x. So like I said before, I'm just going to set these problems up. And then if you have a question about solving it, I'll be more than happy to answer after I finish setting up the majority of these. But again, I want to get us familiarized with reading the word problem, picking out key pieces, and making an equation out of it. So let's go to our next example. This is also from section 7. We have the number of counties, state A, and the number of counties for state B are consecutive even integers. So let's stop right there. The part here, consecutive even integers, is what we got to talk about, because I think in your book as you're reading, it'll say consecutive even integers and also say consecutive odd integers. So let's kind of go through this to make sure you understand this. This is another key thing, is making sure you understand everything in the word problem before we get started. If I think about the word consecutive, consecutive just means back to back. We're lined up consecutive in line. It'll be just one person right after the other. If I say even, we'll think about the numbers 2, 4, 6, 8, and so forth. Those are even numbers. And integers are just whole numbers. So now, if I'm talking about consecutive, how do they go up? So let's just make up an even number. I'm just going to randomly make up an even number. Let's do 30. What will be the next consecutive even integer after 30? It'll have to be 32. So how do we get to 32? Well, if I started with 30, that's my x. How do I get to 32? I took x and added 2 to it. That's what consecutive even integers talks about. In your book, or in my Math Class Plus also, they're talking about what is the next consecutive even integer, and the next one, the first, the second, the third. But what would be the next one in this one? It'll be 34, correct? Well, for this one here, it'll be x. Again, if we represent 30 to be x, this time plus 4. So you see how the numbers are going up by 2's? So I have x, x plus 2, then x plus 4. So this is the first integer. This will be the first integer. This will be the second integer, and so forth. The same thing goes with if we had if this word right here was now odd, consecutive odd integer. So let's just make up a random odd number. Let's do 55. If 55 is x, what will be the next consecutive odd integer? 57. So how do we get to 57? We took x and added how many to it? 2. The next consecutive odd integer will be 59. And how do we get that? We took x, which is 55, added 4 to it, and got 59. So this is the setup as far as x, x plus 2, x plus 4, and so forth. So let's go back to the problem now. So the only thing we're talking about for this one is state A and state B. So we actually just need 2 sets. So we start off with the first state of x that we don't know, but we know the next one is going to be, for state B, it's going to be the consecutive even integers that we discussed. So this one has to be the next one over, which is x plus 2. And then this one here equals to 114, because how do we get sum? The word sum means addition, and then we have the is, which is the equal sign, and is equal to 114. So state A plus state B equals to 114. So again, with this one, we're going to collect like terms. And I think I'm actually going to work this one out because this one's a little tricky at the end, especially when it comes to putting in MyMathPlus. So what are my like terms? I have an x here, I have an x here. So we combine these to make 2x, because there's actually an understood 1 to be in front of both of them. That makes us a 2. The 2 kids drop down because there's nothing alike in the problem, and it's equal to 114. Now, in my previous recording in DMA, I'm sorry, in the first section of DMA 40, I told you to build a wall in examples. Like I said, if you don't like the way I did that as far as building a wall, that's fine. But I figured having a wall and understand there's one side to this wall and there's another side to this wall, it kind of helps us get X by itself. So I told you in the previous recording to make sure you do the opposite when you move things over the wall. So what has to leave? If I'm trying to get X by itself, this 2 has to go over, and this 2 has to go over to this side. And what do I need to move first? Do I move this for 2 first or this 2 first? Well, I told you to always ask yourself this question. Which of the numbers that you're trying to move is furthest away from the X? It looks like this one here is the furthest away from the X. So we're going to do by moving it by doing the opposite. So I have 114, and I'm going to subtract that by 2. That gives us 112. I'm going to drop this down because I didn't use it, and we know these cancel out. So I'm going to create a little bit more room in the problem. Actually, I'm just do it off to the side. 2x is equal to 110. Oh, I'm sorry, 112. And if we do that, how do we get rid of the 2? Because these two are being multiplied together, we're going to take it and do the opposite, which is division. That way these cancel out, leaving us with half of 112 is going to be 56. So 56. And then if this is one of the states, what does the other state have to be if we're talking about consecutive even integers? Well, if this one's 56, the other state has to be 58. How do we check? 56 plus 58 gives us 114. So when we add them together, that's how we got to the answer before. Now remember in the problem, in the last part, if state A has more counties than B, so this is the tricky part. We all think that if we're solving for A, the first number that comes up, 56, is actually going to be state A, but this question says state A has more than state B. So that means that for this particular problem, 56 actually represents state B, and 58 represents state A, because state A has to have more than B. So be careful when you put these two answers into the problem, making sure you have the right one that has more than the other one. So let's go to our next example. This one is from section 8. And the tricky part about this one is just the way it's written. It says solve 3x minus 8y equals to 19 for y. So this case here, we're actually solving for y in this case. So when we redo our problem, The y in this case is what I'm solving for. So let's build our wall. And remember, we're going to move the problem, the term that's furthest away from what we're solving for, which is y. So what is the furthest away? It's actually going to be this 3x. So we do the opposite because this is a positive 3x. We're going to do minus 3x on both sides. This way, this cancels out. We're now going to drop the negative 8y over. And then we have 19 minus 3x. Now we know we're not going to subtract these, and sometimes we might think we can subtract this and get 16x, but we know we cannot do that. And why is that? Because the 19 does not have an x, this is not considered to be like terms, so we cannot do this. So we'll leave it just as is, 19 minus 3x. So how do we get rid of the 8y? Once again, ask yourself, what is the negative 8 doing to the y? Because remember, I want to get y by itself. What is the negative 8 doing to the y? They're being multiplied. So in order to get rid of the negative 8, we're going to take both sides and divide. Now I'm pretty sure my Math++ will accept this answer the way it looks. But if they want you to get rid of this negative sign, we kind of need to do the negative sign here and do it here. So this will be actually going to be negative 19 plus 3x all over 8. Both of these answers should be correct no matter what you put in my Math++. But sometimes in problems, we like to have the negative gone in the problem. So you just kind of change the sign of the 19 and change the sign of the 3x. For this one here, I think I need to go back and get some key part of the information that I forgot. So let me run and get it real quick. So for this one here, I forgot to put in, so let me go ahead and copy and paste this, that t is actually equal to 52. All right, so if t is equal to 52, I can actually go ahead and throw that into the problem. So 52 is equal to 50 plus n. So once again, we're taking this problem and we're going to be solving for n. So what is the question I told you to ask yourself? What needs to move over? We know that the 50, let's draw the wall. The 50 has to go over, the negative 40 has to go over, and the 4 has to go over. So which one of these, the 50, the negative 40, or the 4, is the furthest away from the end? Because once you identify what's the furthest away, that's the actually one that's going to actually move first. So 50 looks like it's going to be the furthest away. So we do the opposite, which this is a positive 50, so I'm going to do minus 50. These cancel out, leaving me with just 2 on this side is equal to n plus, I'm sorry, minus 40. So the furthest away this time looks like it's going to be the 4 because it's kind of like in the basement. So these guys are like in the same room. This guy's like in the downstairs in the basement. So this one looks like it's the next furthest away from the end that we're solving for. So let's do the opposite. What is it doing now? It's being divided by. So what's the opposite of division? It's going to be multiplication. So this way, this one cancels out with this one. And then we lift with on this side to be 8 is equal to n minus 40. And now to bring the 40 over to do the opposite, last step, we're going to add by doing the opposite. And then n equals going to be 48. So So let's get back to the word problems now. So for this particular word problem, perimeter, what do we remember about perimeter? Perimeter, remember, is finding the length of the side of this basketball. This is actually a basketball court. Trying to find the length of the total length around the distance around the whole thing. So the formula that they use for perimeter is going to be P equals 2L plus 2W. So why do we say 2L? Why do I double the L? With the length and the length, there's two of them. So that's why we say 2L, and the width and the width, there's two of them. If you add this one and this one and this one and this one together, we get the perimeter. So let's go back to the word problem. The perimeter of the basketball court is 102 meters. So if I write this equation over, they said the perimeter is 102. So I'm going to change this P to 102. So that's just reading the first part. The length is, so we can stop there. The length is, so off to the side, the length is 6 meters longer than, plus sign, twice the width. I'm going to double it. So the length is 6 meters plus twice the width. So now I'm going to take this equation and replace it where I see the L at, where I see the L at. Because it's a lot difficult to solve for two different variables. I can't solve for L and W at the exact same time in an equation. But if I get rid of the L and replace it with the W, I can just solve for W first and then come back later and solve for L. So let's do that. (102) is equal to 2 times L, so I'm going to say in parentheses 6 plus 2W plus, now the rest of the equation, 2W. So from here, once we solve for W, we get our answer. So down at the bottom, we should have W equals some number. And once we get this some number of W, we take this number and we're going to put it back into this W, times it by 2, add 6, and that actually gives us the L. So now we're going to have W equals something and then L equals something. So for here again, go back to what we discussed in sections 1 through 6. We distribute, collect like terms, get W by itself, get our answer, take this answer, plug it in for W, multiply by 2, add 6 to get L, and then we have our W and L to plug in for this problem. In section 30, DMA 30, we talked about percent decrease. So all I'm going to do is just remind you in this particular one what the formula was. It's the big number minus the small number. And we're going to divide it by the original or the starting number. And then you take this answer and multiply it by 100 to change it to a percent. And that's going to be our answer for this one. All right, so this one here, I kind of combined into both of them because they both kind of are similar, but have one little twist to it. So the first problem says, find the original price of a pair of shoes if the sale price is $36 after a 20% discount. That's a lot going on in this problem, but let's kind of take it to what we do in real life when we buy a pair of shoes. We already know the sale price is going to be $36. If this is the sale price, then this is probably what we're paying for. This is the end result. In order to get to a sale price, what two things that we need to get to a sale price in real life? Well, don't we need the original price? And what is the original price? This is what we're looking for. And then what does a discount mean? Anytime you're doing discount, what are we doing? Are we adding or subtracting? We're subtracting. And then we need to figure out what the discount is. So for here, it's 20% off the original price. So 20% off the original price. So 20%, I changed it to a decimal, off the original price. Remember, X represents original price. Original price minus the discount provides us with the sale price. I'll give you a little hint. When we combine like terms, remember what's understood to be in front of this X. So we're actually doing 1 minus 0.20 and then solving for X for this problem. The reason why I have this one up here because it's pretty much similar. This person here is getting a pay raise and their salary is going to be $30,900. Well, if this is the end result of their raise, this has to go on the back side of the equal sign. How do we get a raise? Well, first, what do we need for a raise? Well, and also too, what does raise mean? If discount means subtraction, raise must mean addition. And what two things do we need to make these equations for a raise? Well, we need our original salary. Do we have it in this problem? No, because that's what we're looking for. We're trying to find last year's salary, our original salary. What's the pay raise? It's going to be a 3%. So 3% of our original salary will give us our raise for this year. So here's your hint again. At the beginning of this problem, there should be an understood 1. So collect like terms and then take it over here to this problem to figure out what our X is going to be equal to. All right. This particular problem here is the toughest problem in DMA 40. So if you actually can understand this problem, then you pretty much are peaked as far as the difficulty level of the word problem in this. So this is here again. This is where it's helpful to have visuals to kind of understand what's going on in the problem. So let's just read it piece by piece. A coffee company wants to create a new flavor of Cajun coffee. Obviously, this problem here has nothing to do with solving the problem. So I'm going to scratch that. Don't need that problem. Don't need that sentence at all. So how many pounds of coffee worth $10? A pound should be added to 20 pounds of coffee worth $3. A pound to get a mixture worth $6 a pound. So once again, that is way too confusing to read the whole thing and try to understand how to create an equation out of this. So let's try to just backtrack. When we go to the store and you see a coffee can on the shelf, I'm going to try my best to do the best coffee can that I can. What is normally located on the bottom right underneath the coffee can? It's usually the price. So we're kind of going to stay similar to what we see in the store and list the pricing on the bottom of each can. Up top is what we're going to designate to be the pounds. So let's just read the first part of this sentence. How many pounds worth $10? If I'm saying how many pounds, guess what? I don't know. I don't have a clue on the number of pounds. That's going to be our X. What is it worth? $10. Next part of the problem should be added. That's our hint there. So we have an added to another coffee can. And then this time we have 20 pounds. So where do the pounds go again? If we were given 20 pounds, that goes on top. How much is 20 pounds worth? 20 pounds is worth $3. So we're going to throw that on the bottom. Next part of the problem, to get. What I've been saying is equal time. Equal means equal. This time to get is going to actually mean our equal sign. We're going to have this time a mixture of the pounds, and this time is going to be worth $6. So let's make this one a little bit bigger. And we already know this one's going to be worth $6. But now, what does a mixture mean? If I take both the mixtures of pounds, this coffee can, this coffee can, and add it together, that's going to be my mixture. X plus 20. And notice again, I put X plus 20 because remember, we cannot add the X and the 20 together because they're not like terms. Now it's time to develop our equation. All you have to do now is take the top and bottom and just multiply them together. So 10 times X gives us 10X. 3 times 20 gives us 60. And this time we have to distribute. You have to take the 6 to the X, and you also have to take it to the 20. You got to distribute to both when we're multiplying. So this one's going to be 6X plus 120. So this is what our equation looks like. 10X plus 60 is equal to 36X. And if we multiply 120 times 6, that gives us, I'm sorry, we already multiplied together. I'm supposed to be just copying it down. Sorry. Let's backtrack. I got ahead of myself. So put this back. So this is just supposed to be 6X plus 120. So again, all we're doing is just writing down the equation inside the box for this one. All right, so this here, we collect like terms. You can bring this 6X over here by doing the opposite, meaning subtraction. Bring this 60 over this side, because once you bring something over here, remember, you always got to bring something else on the other side, put it underneath here, and then finish solving for X. All right, 2 more problems to go. So let's look at this one. Well, actually, this is actually the last one, but there's a couple of things I want to show you in this one. When you start this section in section 10, we're going to talk about inequality signs now. With inequality signs, if you have less than or greater than, you designate this one on a number line to be an open circle. If it has less than or equal to, greater than or equal to, this one will be a closed circle. The reason being is if you have this equal sign, we're trying to include it. If we have just less than or equal, less than or greater than, open means we're not actually including that number. So just keep that in mind when you doing a number line and you see an open circle, just look for the symbols. If you see a closed circle, look for the symbols of less than or equal to, greater than equal to. All right, for this one here, we're actually going to solve just as if this was a equal sign. There's really nothing to it. Maybe there's only maybe one rule that I want to go over and make sure you understand. But if you like to, you can always replace the inequality sign with the equal sign if you're comfortable solving with equal signs. And in the end, we'll just come back and put it back in. So here we do our distributing like so. Times here. That gives us 20x minus 4. And then distribute here and distribute here. This gives us 18x minus 72. And it does not matter. Let me put my little wall up. It does not matter what you decide to solve for. You can bring the 18x over here, or you can bring the 20x over here. I know most problems probably bring the 18 over here, but I just want to kind of show you a rule. So I'm going to do things just a tad bit differently, just so you can get this rule written down. So I'm going to bring over the 20 by subtracting. And because I brought the 20 over this side, the 72 now, I'm going to bring back over to the other side. So I'm going to add 72 to both sides. So then we know that this one here cancels out, and then this one cancels out. -4 plus the 72 will give us a positive, I'll do this in black, 68. Over here, if I do 18 minus 20, that gives us a -2x. So here's the rule that you need to write down for the problem. If you are dividing, because the last step here, we need to divide both sides by -2. If you are dividing by a negative number, dealing with inequality signs, you need to always flip the inequality sign after dividing. This is the rule for only division, and if you're only dividing both sides by a negative number. So let me kind of explain it. 68. So this side I'm going to divide by -2. So this gives us -34. And because I divided by a negative sign, this inequality gets flipped. So now it was less than, that was over here, it would be greater than. And then I have x over here. If you kind of like your x writing on the left side, this can be this is the answer to the problem, but sometimes we always like the x on the left side. So you can just go back and just flip it back. Because remember the inequality sign is pointing to the x. So for this case here, when you flip it back, make sure it's still pointing to the x and put the -34 on this side. So both of these will be our answer to the problem. So I have all the problems up here listed. So I'm gonna go back to my Google Meet real quick. I'm gonna pause it.